morning, good morning. Hopefully, your test went well. Technically, this is still in the same unit, it's just not on your test, so that's why we did it after. But this will be our last little thing, and then we'll learn something new. So it says solving systems of equations graphically. It says on a graph, the solution. Oh, come on, Ben. There we go. The solution is the point of intersection. Okay, the solution is written as an ordered pair x, y. All right, so what we're looking for is we're looking for where two lines cross, and we always do x, which is to the left or right first, and then y, which is up or down. So here, this is the point where those two lines cross. So this, I go right 3 and down 1. So this would be 3, negative 1. Okay, this is the point of intersection, which means this is the only point that both equations have in common. And this is the, oh, I got to scroll down a little, hold on. And this is the only point. Oh, only goes there. Silly goose. Only point that will make both equations true. All right, so what we're going to do is we're going to graph both lines and then see where they intersect. Okay. We've learned how to graph linear functions before. We're using that slope-intercept form. Okay, so our first job is to graph both equations. All right, so our y-intercept is negative 1 because it's our constant, and our slope is 2, and I'm going to write it as 2 over 1 so that it's written as a fraction. So I'm going to start this at negative 1 on the y-axis, and then from that negative 1, I'm going to go up 2, right 1, up 2, right 1, as many times as I can. And then I'm going to go the opposite way, which would be down 2, left 1, down 2, left 1. And once I have all the points on there I can do, I'm going to connect them the best I can. You could use a ruler, because there's rulers in my room, so you could pause it and grab rulers, make sure yours are nice, pretty, and straight so that we know they cross at the right spot. I also would suggest when graphing these, sometimes it's nice to use different colors, so that way you can see which one goes from what. Okay, then we're going to graph the second equation. The second equation says negative 1/2 x plus 4. So that means my y-intercept is 4, and my slope is negative 1 over 2. And I'm just putting the negative on the top. Okay, so my y-intercept is positive 4. 1, 2, 3, 4. Oh, right here. Okay. And then from that point, my slope is negative 1 over 2, which means I'm going to go down 1, right 2. Down 1, right 2. I can't go any further, so I'm going to try the opposite, which is up 1, right 2. And that's all I can do. So then I'm going to use a ruler if I have one. Connect my dots. And the last thing I want to do is I want to find the point of intersection. That would be right here. This is where those two lines intersect. So from the origin, this is right 2, up 3. So this would be 2, 3. Okay, so hopefully you're just remembering how to graph these. And that part's a review. And the only thing that's new is finding where they cross each other. So we're going to graph both equations. So we have y equals 3/2 x minus 4. So our y-intercept is negative 4. Our slope is 3/2. So I'm going to start at negative 4. And then from negative 4, I'm going to go up 3, right 2. As many times as I can. If I try to go the opposite way, I can't go down 3. So those are all the points I can do. Remember that you have to have a minimum of 2 points. You must have at least 2 points. Okay, on equation 2, we have y equals negative 2x plus 3. My y-intercept is 3. My slope is negative 2, and as a fraction, this would be over 1. So I'm starting here at 3. And then from that, I'm going down to right 1 as many times as I can. Oh, that's the wrong spot. It's like right there. Okay, and then up to right 1. And then I'm drawing my line all the way through my grid. It looks like these two cross right here. I'm looking for the point of intersection, also known as the solution. So from the origin, that is right 2, down 1. So this would be 2, negative 1. Okay, there's a couple of things that I want to talk to you about. So if you want to flip it over to the back, there's just a few things I want to talk to you about really quickly in case you see them at some point in time. You could end up with 2 lines that look like this. So there's one. Ooh, there's the other. Okay, these are called parallel lines. And when you have parallel lines, this means no solution. In order for it to be no solution, that means that they have the same slope. So if you have 2 lines and you're like, oh, they didn't intersect, but they don't have the same slope, it might be that one of your lines isn't graphed correctly, so you would want to double check that. Okay? You could also, oh, hold on just a second. Okay. You could end up where you graph a line. So it's like, yay, it looks like this. Hold on just a second, Bubba, I'm almost done. And when you go to graph the next line, it looks exactly the same. It's right on top of that last one. Okay, this is what we would call infinitely many solutions because they're the exact same line. Well, that seems like a great place for us to stop. So I hope y'all have a great rest of your day.